All right, 9.2. Tests about a population proportion. Thank you for watching. Uh, this first part here about conditions for performing a significance test about proportion should look familiar to you. I should make this or equal to. There we go. The one thing you might notice different. This is what is usually all our null hypothesis. Okay, that's usually what that variable right there, p sub 0, is usually used for our null hypothesis. Wherever that value is, that's what we put in. So go ahead and I'll pause it, jot this down real quick, move on. One of the things we'll be calculating is the test statistic, and it measures how far a sample statistic diverges from what we would expect if null hypotheses were true in standard units. And we calculate by statistic minus parameter over standard deviation of the statistic. We'll do some examples with that. All right, so go ahead and read this example right here. And the first thing it asks us to do is calculate the test statistic. That's going to be really brutal to say this video. What did the formula say? It said statistic minus parameter. The parameter was what? 0.8. And what was the first number going to be? The statistic. What statistic? It's 41 over 60. 41 over 60 comes out to be approximately 0.683. It's all divided by what? What is it divided by? The standard deviation of the statistic. How do you find standard deviation of statistic? Well, you do square root 0.8 times 0.2 all over number of numbers, which is 60. And what do you get when you solve that? You get negative 2.27. So that's our test statistic for part A. Now, part B, find the p-value. It says table A or technology. I'm going to use technology because that's cooler. When using technology, you're using normal CDF. Normal CDF, lower, negative 1,000. You can make it 0 if you want, I don't care. Actually, no, it can't be 0 because in the upper is everything less than negative 2.27. So as long as it's something obnoxious, negative number for your lower. Upper, negative 2.27, mean 0, standard deviation 1. And out should come 0.0116. You found it, the p-value. There you go. B, that's A. There we go. Right. The 4-step plan for finding a significance test. Go ahead and jot these down. We should be doing it for problems like we did on the previous question, but we're going to do that in a moment. And just go and jot down. I'll say what I'm about to say. So for solving one sample z test for proportion, this formula should look familiar because that's basically what we did to solve the previous problem, right? And what we're doing here is we're testing the hypothesis that the proportion is equal to the null. All right, another word problem. We're going back to the parking at a high school, like we did in class. So try to read it. I'll let you read on your own. Pause if you need to. So S, let's state. So if we're stating null is equal to, not equal, I should say the P is actually equal, but null in general is P is equal to 0.37. And that's versus the other, which is P is greater than 0.37. Now, time to plan. Oh, wait, no, we didn't say what P is. I'm sorry. Let's state what P is. What does P represent? P represents, because you're not going to be able to read where I write with this, so I'll say it loud. P is the true proportion of all students who are satisfied with the parking situation after the change. Now it's time to plan. Plan. One sample z-test for P. That's all you have to do. One sample z-test for P. So now that we did that, is it random? I want that. Is it random? Yeah, it's definitely random, right? Yes, it is random. Is it 10%? 10%? Yes, because 200 is less than 10% of 2,500. So we're all good. Now I gotta check large counts. 200 times 0.37 and 200 times 0.63. They're all greater than or equal to 10. So large counts. Good. Now we can do our third step, which is do. Tell me do. Z, if we calculate it, to find a z-score, I'm going to go in a different color and go to the right because I'm running out of space. So 83 over 200 is 0.415, and minus the 37%. And then we're going to divide that by the standard deviation. And when you divide that, you're going to get a z-score of 1.32. Now to find the p-value, you're doing normal CDF. And you're going to keep the mean 0, standard deviation 1, but you're going to use the z-score of 132. And then, so that's going to be your lower. It's everything greater than that, so your upper is whatever, some big number. Upper, we'll do 1,000. Then 0, 1, and you'll get 0.0934. Now, what does that mean? Well, that is bigger than your alpha of 0.05. And what does it mean when it's bigger than your alpha of 0.05? When your p-value is bigger than alpha, fail to reject the null. Okay? Fail to reject the null. Okay? So, what can our last part, conclusion. I'm sorry, I don't have space for this. Conclusion. What can we conclude? We do not have convincing evidence that the true proportion of all students who are satisfied with the parking situation after change is greater than 0.37. Okay, so not enough evidence. So I gave you the formula what you should write down. Let me talk a little. So because this number right here, that 0.09, is a little too big, bigger than 0.05. That's telling us there's still a fairly good likelihood that your null hypothesis is in fact true. Okay, so we're not convinced that the students are satisfied with the parking situation. All right, we got another word problem about the DMV. What a fun place. The DMV claims that 60% of teens pass their driving test on the first attempt. I was not one of those 60%. It took me 2 tries. Parallel parking. Always get you. Investigative report examines an SRS of the DMV records for 125 teens. 86 of them passed on the first try. Is there convincing evidence at the alpha equal to 0.05 significance level that the DMV's claim is incorrect? So here's step 1 completed. We have null, alternative, right? And there we go. Next, plan. So when we plan, of course, we gotta check the conditions. Is it random? Yes. Random sample. Is 10%. Yes, 125 teams is most definitely less than 10%. Guaranteed, right? There's a lot of teams out there, right? How about large counts? Well, abbreviate to LC. Large counts. 120 times 6 is greater than 10. Guarantee it. And so is 120 times 0.4. Also greater than 10. We're all good. Now let's do. We need to find the z-score. So once again, we have 60%. So we got 86 divided by 125 will get you 0.688 minus 0.60. And then we use that lovely standard deviation formula we used previously. That's square root of p times 1 minus p all over n. And then what do you get? You will get I will get 2.01. So go find the p-value, same story. Normal CDF, 0.01, 1,000. Leave those other numbers 0 and 1. You will get 0.0444. Now our conclusion. Since our p-value is less than alpha, 0.05, that's less than 0.05, right? You agree? Yeah. We reject our null hypothesis because it is very likely it won't be that. So what we're going to say, there is convincing evidence that the true proportion of teens who pass the driving test on their first attempt is different from 0.60. All right. All right, last 2 definitions, and that'll be it for today. We will discuss a little more definition on these last 2 things in class, but we did the major stuff. Hooray! Appreciate you watching. I'll see you later. And bye-bye.